So now we've been talking about these salt uh, preparation methods. TK, we did past paper questions as well on this. So the next thing that we're going to talk about is ionic equations. TK, so we'll be dealing with ionic equations, and we're going to learn what are ionic equations in the first place. So in ionic equations, we've done equations. TK, we've done 4 equations. So an ionic equation is no different. It's the same equation, and in ionic equations, what you do is, what happens is that a lot of times when you have a reaction, okay, we did 4 reactions. We did metal plus acid. किसी का mic on है. अच्छा, we did metal plus acid, salt plus H2 बनता था. अच्छा, we did base plus acid, uh, and that would produce salt plus water. And we did carbonate plus acid, that would produce salt plus water plus carbon dioxide. And we did ammonia plus acid, and that would produce ammonium salts. And there was one more. We did ionic precipitation as well. That was another separate reaction. So we did ionic precipitation as well. Now, ionic equation, I mean, all the equations that you've written so far, all of the equations that you wrote down, uh, they have a different version as well, and that's known as the ionic equation. What that basically means is, in ionic equation, I mean, the multiple steps. The equation is the same. It's the same reaction as the ones that we've already covered, but there's a different way of writing those reactions. The different steps. Step number 1 is you write the states. So what that means is that if something is soluble, then it's aqueous. So that indicates it's aqueous. And if something is insoluble, then that means it's a solid. Like marble is insoluble, doesn't dissolve in water, so it's going to be a solid. So step 1, you write states. Step 2, you rewrite the equation in dissociated form. And I'll explain that just in a while. So rewrite equation in dissociated form. If substance is aqueous. Then you've got step 3. Step 3 is you remove spectator ions. So now a few things. I'm talking about dissociated form. So well, we did study what dissociated is. I told you that if something is aqueous, specifically when something is aqueous, it's going to dissociate. So for example, you have NaCl. NaCl is an ionic compound. It's got sodium ions, which are positive, Cl ions, which are negative. So it's positive and negative ions are all connected to, or joined, or strongly attracted to each other. Got this one is going to be negative, then positive, and then another negative. Anyways, that's your ionic substance. So all your salts they've got acids, bases, and salts. They've got positive and negative ions. All of them are something nice. Uh, so you've got NaCl. When it's aqueous, when you mix it in water, when you stir it in water, what happens is that the ions dissociate. The positive and negative ions, they all scatter. So that is what is meant by the word dissociate. That when you vigorously stir them in water, all the crystal and all the ions, all the ionic bonds, all the strong forces of attraction are going to they're going to break because you're stirring them vigorously, and the ions dissociate, and the ions are not able to attract each other again because there are lots and lots of water molecules that are in the way, billions of water molecules. So they're not going to allow them to sort of join up. So that means when NaCl is aqueous, what that basically means is that the sodium ions and the Cl ions are now scattered. They're separate now. So that is what is meant by dissociated form. So anything that's aqueous, specifically if it's got ions, the ions are going to get scattered and the ions are no longer going to be together. So instead of writing them Na and Cl together, you're going to write Na ions and Cl ions separately because now they're dissociated, now they are scattered. ठीक है, is this clear? Wasam, Amna, is this clear? Minahil, clear है सारों को?
Yes, sir.
अच्छा, this is dissociated. तो अगर HCl aqueous होगा तो that means H+1 and Cl ions are going to be separate. ठीक है, they would be scattered in the water. ठीक है. अच्छा, so what does that have to do with the equation? So what's going to happen in the equation is, like if I pick a basic equation like magnesium, which is solid, reacting with the acid HCl. So how is the salt produced? The H is going to be replaced by Mg. It's going to be Mg2 plus. Cl is -1, so it's going to be MgCl2 plus there's going to be H2 gas. और बाकी इसको balance कर लेते हैं. Now the first step is you write down the states. When you write down the states, Mg is a metal, that's a solid, right? So I can show you HCl is the solution. So like if you just Google magnesium plus HCl, the magnesium metal is going to be a solid. Okay, for example, this over here. So the magnesium ribbon or metal, that's a metallic piece, that's going to be a solid. The acid is going to be in the form of a solution. It's going to be aqueous. So Mg plus HCl. HCl is going to be aqueous. It's in the form of a solution. A salt is going to be produced. Remember, all chlorides are soluble. Okay? All chlorides, Cl-1, Br-1, I-1 are soluble except for silver and lead. So this is soluble. And hydrogen is a gas. So there would be a gas being produced. So you see the bubbles of gas that are getting formed as a result of the reaction. So this is the reaction. TK, you already know this. I've written down the states. So what I told you was the second step is anything that's aqueous. TK, for example, if you've got HCl, it's aqueous. Then that means H+1 and Cl-1 ions are all scattered in water. They're all separate. So we're going to write substances that are aqueous in dissociated form. So this is what we are going to do. Second. So this is what we are going to do, and substances that are aqueous are HCl. HCl is aqueous and MgCl2 is aqueous. So that means their ions are going to get scattered. So Mg is going to remain as it is. It's going to be a solid. HCl over here is in aqueous state, so that means the H+1 and Cl-1 ions are now separate. So I'm going to write them separately. It's going to be 2H+1 ions and 2Cl-1 ions. So they are all separately scattered in water. Then you've got MgCl2. That is also aqueous. So that, what does that indicate? If it's aqueous, that means the ions are now scattered in water, just as you can see at the top. So the Mg2 plus ion and the Cl ions are now scattered. And also remember, you use the small 2. Small 2 indicates that they're all together. For example, H2, that means the two hydrogen atoms are all together. Use the big 2 when they're scattered, when they're separate. So because the two Cl ions are going to be scattered, they would be all over the place. They would not be connected together. So I'm going to write it as the big 2. That means you still have two Cl ions, but they're now no longer together. If they were together, then I would write Cl2. But since the ions are getting scattered, so I'm going to write 2Cl minus 1 ions. Is this clear?
Yes, sir.
Saneem, is this clear? Subhan?
Yeah, sure.
Plus you're going to have H2 gas. Now that's a gas. That's not going to dissociate. So it's only HCl which is dissociating, the ones that mix in water, and MgCl2 that is dissociating. So your equation is the one that you see over here. So that means in the solution the H plus 1 and Cl ions are now separate. In the solution the Mg plus and 2 plus and the 2 Cl minus 1 ions are actually going to be separate. Now you're going to look for spectator ions, the ions or substances that are not doing anything. So first one, look at Mg. Mg is doing something. It's turning into Mg2 plus, so that means it did something. Look at H plus 1, it turned into H2 gas, so that means it did something in the reaction. Now look at Cl minus 1. What is Cl minus 1 doing? It's aqueous, it's dissociated, it's in water. And after the reaction, it's still in the same form. So that means this ion is not doing absolutely anything in the reaction. It's not even undergoing any sort of change. So it's not even involved in the reaction. So nothing happens to it. So that indicates that this Cl minus 1 was just a spectator ion. It was just watching the other ones do the reaction, and nothing happened to it. Is this point clear?
Yes, sir.
ठीक है, बाकी को clear? Bassam, is this clear? Subhan, Turhan, Saneem, is this clear?
Yes, sir.
Yes.
Achha, so I'm going to repeat everything. You have the same equation, you write the states. Whenever something is aqueous, that means the ions are going to all get scattered. So when HCl is aqueous, that means the 2H plus 1 and the 2Cl ions are going to be separate. They would all be scattered in water. And if MgCl2 is aqueous, that means the Mg2 plus and the 2Cl ions that make up MgCl2, they're all going to be scattered and they would be separate or away from each other. And H2 is a gas, so that's not, I mean, its ions, it doesn't even have ions in the first place. That's a gas. Mg is a solid metal. So again, it doesn't have ions. So you're going to remove the Cl ions because they are spectator ions. So I'm going to define what a spectator ion is. So it remains unchanged during the reaction. And does not participate. So what we're going to do is, I'm just going to remove the Cl ions and I'm going to rewrite the equation as it is. So it's going to be Mg solid, and that is reacting with 2H plus 1, which is aqueous. And it is producing Mg2 plus. Plus H2, which is a gas. Okay, that's your final ionic equation. Is this clear to everyone?
Yes, sir.
So I'll repeat the steps. You write states, you dissociate, and then you remove spectator ions, the ones that are not doing anything. So your equation now consists of only those substances that are actually taking part in the reaction. You've just removed all the substances that are not taking part in the reaction. So we're going to try and do another one, which is So let's try and do another one. I'm going to talk about a carbonate reaction, sodium carbonate reacting with, let's say, nitric acid. So salt, water, and carbon dioxide, the H is going to be replaced by, so the H is going to be replaced by Na. It's going to become NaNO3. Na is +1, NO3 is -1. Plus there's going to be water and carbon dioxide. That's my reaction. I'm going to balance this equation. Okay, it's the same reaction that we studied previously as well. There's going to be 2HNO3. So write down the states first. Na is group 1. Group 1, everything group 1 is aqueous. Acids are already aqueous. Na group 1, NO3, all the compounds are aqueous. Water is a liquid and CO2 is a gas. So dissociate aqueous ions. So we're going to start dissociating. I'm going to dissociate this and this next one, and we're going to dissociate these three. So we're going to dissociate all of them. Na2CO3 contains 2 ions. So when you mix it in water, the ions are going to get scattered. So which 2 ions does it have? It's got Na plus 1 and it's got CO3 minus 2. And then 2 sodium ions. So in water, when you stir them vigorously, the ions are going to go their separate ways. Similarly, the HNO3 is aqueous. That means the H plus 1 and NO3 minus 1 ions are going to be separate. So it's going to be 2H plus 1 plus 2 NO3 minus.
Sir,
Yes.
आपने Na के किस तरह आपने डिसाइड किया कि 2 आयंस हैं Na के?
नहीं, फॉर्मूले में Na कितने हैं?
2 आयंस.
अच्छा, एक तो वो है कि जब आप फॉर्मूले में लिखते हो ना, तो आप छोटा 2 छोटा 3 यूज करते हो कि 2 सोडियम्स हैं, 1 C है, 3 ऑक्सीजन है, दे ऑल ग्रुप टुगेदर. ठीक है, क्लियर है?
लेकिन जो CO3 है उसमें भी तो
नहीं,
फिर
लेकिन
3
CO3
होगा
मैंने
तो
वो पहले बताया था, CO3 always remains as one ion.
Okay.
ठीक है, जैसा NO3 always remains as a nitrate ion. ठीक है, उसको आपने एक चीज कंसिडर करना है. ठीक है,
Okay.
तो जब वो सेपरेट हो जाते हैं ना, मतलब ये वाला काम होता है कि किधर बी का, जब आप उसको पानी में मिक्स करते हो, अब वो Na2CO3 भी होगा तो आयन सारे सेपरेट होंगे, बिखर जाएंगे, स्कैटर हो जाएंगे. तो कितने सोडियम आयंस होंगे? देयर वुड बी 2 सोडियम आयंस. ठीक है, and if you dissolve it in water, all the ions total is कितने ions है? There are 2 sodium ions, there's 1 carbonate ion. So the sodium ions वो भी scatter हो जाएगा. The other sodium ions would also fly away in different direction. Carbonate ion ये आप चम्मच से उसे हिला रहे हो, तो all the ions are getting scattered. तो in total अब आप बड़ा 2 use करोगे. बड़ा 2 का मतलब है you still have 2 sodium ions, but they're no longer together. Similarly with nitric acid, it has, ये देखना पड़ेगा, आइडेंटिफाई करना आना चाहिए कि by just looking at the molecule, you need to understand which 2 ions are there. ठीक है, for example, NaNO3 है, तो कौन से 2 ions है? That's also aqueous. That means it's got Na plus 1 और NO3 एक अलग ion है, that's NO3 minus 1. तो ये 2 and 2 हो जाएंगे. ठीक है, अच्छा, प्लस अच्छा, वाटर और कार्बन डाइऑक्साइड वो वैसे दे डोंट हैव आयंस. ठीक है, रिमेंबर सिर्फ एसिड, बेस एंड सॉल्ट्स डिसोसिएट होंगे. ये मैं लिख भी देता हूँ यहाँ पे. ये जो सब्सटेंस की हम बात करें ना कि रीराइट सब्सटेंस इन डिसोसिएटेड फॉर्म्स, तो वो जो सब्सटेंस है ना, दैट्स जस्ट एसिड्स, बेसेस एंड सॉल्ट्स बिकॉज दे कंटेन आयंस. ओनली दे आर गोइंग टू डिसोसिएट. अच्छा, ये आपके सारे डिसोसिएट हो गए. अब रिमूव करना है स्पेक्टेटर आयंस. मुझे बताओ कौन से आयंस हैं इस पूरे रिएक्शन में? द मिडिल पार्ट इज वेयर द रिएक्शन, ये वो एरो है. इस पूरे रिएक्शन को देखो, मुझे बताओ कि कौन से 2 आयंस हैं जो या कोई आयन है जो कुछ कर ही नहीं रहा. Saneem says NO3. So look at NO3 minus 1, NO3 minus 1. So that means it's exactly the same. इसका मतलब it's not doing anything in the reaction. ठीक है? Why are you writing it in the first place? I mean, you don't need to write it because it did absolutely nothing in the reaction. उसके अलावा बताओ which other ions are not doing anything in the reaction?
2Na.
तो 2NAB पहले भी था, बाद में फिर वैसे का वैसे ही पड़ा हुआ है, तो इसका मतलब इसने कुछ किया ही नहीं रिएक्शन में. बाकी सारी चीजें they underwent changes. 2H plus 1 changed into H2O, CO3 changed into CO2, so that means a reaction did happen. So rewrite. Now we've removed the spectral ion, so rewrite the same equation but without the spectral ion. CO3 minus 2 aqueous plus 2H plus 1, that's aqueous. And on the other side, you've got Minail आपका annotation on हुआ, एक second. And on the other side, you've got water, which is a liquid. And you've got CO2, which is a gas. तो ये आपके पास you have finally gotten your ionic equation. अच्छा, इस तरह आप किसी भी रिएक्शन के बारे में you can construct the ionic equation in a similar manner. So let's try and find another one. ठीक है, pick a random equation. Let's do KOH with H2SO4. So it forms K2SO4 plus water. ठीक है, that's the acid-base reaction. H की जगह ना there's going to be K coming in. Now K group 1, that's aqueous. H2SO4, that's acid. That's obviously aqueous. K group 1, that's aqueous, and H2 is a liquid. So anything that's in that's aqueous, that's going to be dissociated. So K is plus 1, OH is minus 1. The two ions are going to be separately mixed. I mean, they would be just roaming around independently in water. तो aqueous state में the two ions are going to be scattered.
Sir,
Yes.
balance नहीं करेंगे.
हाँ, balance पहले करना है. 2 और 2, तो ये 2K plus 1 होगा और 2 OH ions. ठीक है, तो remember this. ठीक है, important point. It has to, remember, equations always have to be balanced no matter what. ठीक है. अच्छा, H2SO4 by just looking at it, find out which two ions are present. There's an SO4 minus 2 ion, there's an H plus 1 ion. ठीक है, so it has H plus 1 and it's got SO4 minus 2 and the two H plus 1 ions. ठीक है, write it with a big 2 now. क्योंकि the two H plus 1 are no longer joined up in one molecule, they're now separate. ठीक है, your spoon stirring vigorous, that has separated them. अच्छा, दूसरी side पे you've got K2SO4, which is K plus 1 and SO4 minus 2. And again, there's going to be 2 K plus 1 ions. And you've got 2H2O, which is a liquid. Now, here's a reaction, and which ones are spectral ions? So SO4 minus 2 is gone, not doing anything.
2K.
ठीक है, K is gone because it didn't do anything. The rest are going to be there. So the ionic equation is going to be 2H minus 1 plus 2H plus 1, and it forms 2H2 on the other side. So these are aqueous. And H2O is a liquid. ठीक है, is this clear?
Yes, sir.
अच्छा, we're going to do one more example, and this one is going to be बाकी वो clear? Mirahil, Vasna, Saneem, is this clear?
Yes, sir. Yes, sir.
So we're going to do another example, which is now going to be उसमें कोई insoluble चीज डाल देते हैं, ठीक है? Let's say I have aluminium oxide and that's reacting with nitric acid. तो salt बनेगी, H हटा दो, it's going to be Al उसकी जगह आ जाएगा, so it's going to be AlNO3 thrice plus I think 3 H2 gas molecules. So this is a equation. Remember oxides का मैंने क्या कहा था, सिर्फ group 1 वाले और group 2 के थोड़े से, ठीक है, वो soluble होते हैं. So this is a solid. If you look at the solubility table, acids are aqueous. NO3 जिसमें भी आएगा, NO3 is always aqueous and H2 is a not a liquid, it's a gas. जो भी चीज सॉलिड होगी ना, उसके आयंस जुड़े हुए रहेंगे, ठीक है? मतलब इफ समथिंग इज सॉलिड, उसका मतलब है कि इट्स नॉट डिसॉल्विंग. कहां गया ये वाली चीज? इफ समथिंग इज सॉलिड, उसका मतलब है कि द आयंस आर नॉट ब्रेकिंग अपार्ट एंड दे आर नॉट डिसोसिएटिंग. तो अगर एल्यूमिनियम ऑक्साइड सॉलिड है ना, उसका मतलब है ये भी सारे आयंस इंटैक्ट हैं, इट्स नॉट डिसॉल्विंग, ठीक है? तो whenever something is solid, you don't dissociate them. So Al2O3 is a solid, no dissociation. Nitric acid, that's aqueous, that will dissociate. Aluminum nitrate would also dissociate. So aluminum oxide को तो वैसे का वैसे ही उठा के रख दो, the ions would still be joined up. Nitric acid, उसके जो ions है ना वो soluble है, तो पानी के अंदर उसके जो ions हैं वो सारे अलग अलग dissociated form के अंदर exist करेंगे. Is this clear?
सर
Yes.
जो सॉलिड है उसको क्या करेंगे?
उसको उसी तरह रखोगे, उसको डिसोसिएट नहीं करना.
ओके
मतलब उसके आयंस तो स्कैटर नहीं हुए ना, सॉलिड वो इसलिए सॉलिड है ना,
जी
क्योंकि क्योंकि उसके आयंस स्कैटर ही नहीं हुए, तो उनको आपने जोड़ के रखना है, ठीक है? अच्छा, एल्यूमिनियम नाइट्रेट, कितने एल्यूमिनियम आयंस हैं? 2 एल्यूमिनियम आयंस हैं और नाइट्रेट जो है आई थिंक 6 NO3-1 आयंस हैं एंड देयर आल्सो aqueous, यानी वो आयंस सारे स्कैटर हो गए और H2 गैस है. अब मुझे बताओ which one is a spectator ion out of them?
सर
Yes.
नॉट अंडरस्टैंडिंग के आपने पीछे सोडियम को के साथ आपने नहीं लगाया था ना 6 जो भी उसका था आयोनिक नंबर
नहीं, आयनिक नंबर क्या मतलब? एक सेकंड.
नंबर ऑफ आयंस सॉरी
सोडियम के साथ मैंने लगाया होगा. सोडियम कहाँ गया है?
NO3 आई मीन सॉरी NO3 के साथ
कितने, मतलब वो काउंट कर लो ना, खुद काउंट करो कितने आयंस हैं NO3 के.
तीन तीन है ना
नहीं, NO3 एक चीज है ना,
जी
तो
तो
NO3,
दो हैं
हाँ तो NO3 तो मैंने कहा था उसको एक चीज कंसिडर करना है ना, वो एक आयन है ना. तो कितने आयंस हैं? 2 आयंस है ना, तो 2 NO3 आयंस है
जी
ना,
ठीक
ठीक है?
लेकिन आपने किसी एक के साथ नहीं लगाया था मुझे याद नहीं आ रहा आपने किसके साथ नहीं लगाया था
सारों के साथ ही लगाया है. कार्बोनेट के साथ ही लगाया था, कार्बोनेट एक ही था,
तो वो क्यों नहीं लगाया था मुझे नहीं समझ आया
क्योंकि वो एक ही है. मतलब कितने कार्बोनेट आयंस हैं? बस
फिर
CO3,
सोडियम के साथ क्यों लगाया था
क्योंकि सोडियम 2 थे ना,
अच्छा
ठीक है? मतलब कार्बोनेट का याद रखना, ये जो CO3 है ये इसका फॉर्मूला है, और ये जो है ना एक
हाँ
एक
हाँ
चीज है. अगर उसे ब्रैकेट डाल के फिर लिखा होता ना, 2 लिखा होता, तब
हाँ
उसका
हाँ
मतलब होता कि कार्बोनेट 2 हैं,
से ठीक
ठीक है?
ठीक
अच्छा, अब वो किधर गया हमारा, ये. अच्छा, इधर NO3 मतलब आयंस जो होंगे वो 6 ही होंगे, ठीक है? मतलब NO3 को आपने एक चीज कंसिडर करना है, ये मतलब सॉरी, तो NO3 को आपने एक एंटिटी कंसिडर करना है. अच्छा, इधर NO3 कितने हैं? वो 3 थे, लेकिन अब 2 मॉलिक्यूल्स हैं तो 6 हो गए, ठीक है? सो विच वन इज द स्पेक्ट्रल आयन इन दिस इक्वेशन?
NO3
ठीक है, सो NO3 इज गॉन. तो आपने क्या करना है, आपने बस यही इक्वेशन उठानी है, बस इसको ना NO3 को बीच में नहीं लेके आना. तो एग्जैक्टली सेम इक्वेशन, बस मैं ये NO3 वाला पार्ट जो है ये रिमूव कर रहा हूँ, क्योंकि वो कुछ कर ही नहीं रहा था रिएक्शन के अंदर, तो उसको बीच में वैसी फजूल में लिखा हुआ था। So that's it. That's your ionic equation. अच्छा, what an ionic equation tells you is it tells you what actually is happening. वो जो फालतू की चीजें बीच में इक्वेशन में डली होती है ना, जो कुछ कर ही नहीं होती, उनको जब आप निकाल देते हो तो आपको पता लगता है कि वो जो NO3 वाला था ना, उसका कोई काम नहीं था, उसकी जगह कोई और आयन होता ना, Cl-1 होता, तभी ये रिएक्शन होना था। ठीक है, क्लियर? मतलब वो इंडिकेट करेगा कि साइन की जरूरत ही नहीं है, कि अगर आप इस टेंशन में बैठे हो ना कि यार मेरे पास तो HNO3 है या मेरे पास HCl है, HNO3 नहीं है, तो NO3 का कोई काम ही नहीं है, उसकी जगह अगर Cl-1 भी होता तो कोई फर्क ना पड़ता। ठीक है, इज दिस क्लियर?
यस सर।
Yes, sir.
अच्छा, अब एक काम कर लो, एक क्वेश्चंस कर लो कि इक्वेशन, एक दो इक्वेशंस तो मैं खुद ही लिख देता हूँ कि NaOH प्लस फॉस्फोरिक एसिड, सॉलिबिलिटी देखो, क्या बनेगा, Na3PO4 प्लस 3H2O। इसकी स्टेट्स वगैरह लिख के ना, इसकी सॉलिबिलिटी, वो आयोनिक इक्वेशन खुद ही बनाना। ठीक है, एंड देन यू गॉट कैल्शियम कार्बोनेट प्लस हाइड्रोक्लोरिक एसिड। ठीक है, इक्वेशन वाला काम मैंने खुद कर दिया है, CaCl2 प्लस वाटर प्लस, और एक तीसरी कर लेते हैं कि स्टेट्स खुद ही लिखनी है, वो उसको देख लेना। अच्छा, आयरन 3 हाइड्रोक्साइड प्लस 3H2O। इन तीनों की ये बैलेंस इक्वेशन है, तीनों की अलग अलग आयोनिक इक्वेशन मुझे बना के आप भेजो। ठीक है, एंड आई एम पोस्टिंग दिस इन द ग्रुप एज वेल।
सर ऑलरेडी बैलेंस्ड है।
हाँ, ये सारी ऑलरेडी बैलेंस्ड है। ठीक है,
ओके।
एंड रिमेंबर आयोनिक इक्वेशन जो है वो भेजनी है। तो ये आप कहो, ये इस पे मैं वेट करूँ व्हाट्सएप पे। ठीक है, फॉर द आंसर। ओके देन, टेक केयर, अल्लाह हाफिज।